Hello guys, welcome back to Maison African Motives, still on Mathematics N5. We are going to continue on the question paper that we were focusing on June 2022 exams that we had. Now in question number 3, we have some questions that we are going to check and see. Actually, everything on question number 3. We are given the first part without wasting much time. 3.1, we are given f of x as a function where we are given to determine the coordinates of the point of inflection of f of x, and that's 2 marks to determine the coordinate of the point of inflection. All right, I'm going to have my expression here. That's 3.11. So I'm going to just have my expression here so that it can be easier for us to work out. All right, so this is f of x, which is given as 2x cubed minus x squared minus 4x plus 1. Take note of your expression, guys. So to find the point of inflection, what are we supposed to take note or to take into consideration? We must understand that for the point of inflection, the second derivative must be equal to 0. That's the concept. The second derivative must be equal to 0. So if the second derivative is supposed to be equal to 0, that means we are supposed to just find the derivative there. First derivative first of f of x, in this case, we're going to have 2 by 3, which is 6x squared. Here we're going to have 2 by 1, which is negative 2x, and this is just negative 4. That's a constant, which is 0. We find again the derivative, that's the second derivative, 2 by 6, which is 12x minus 2, and the 4 is going to be a 0. So this must be equal to 0. All right, so that means it's now an equation that we are going to have 12x minus 2 is equal to 0. So 12x is equivalent to 2. Divide by 12, definitely both sides. So your x is going to be 1 over 6. So our x being 1 over 6, then to find the point, so you're supposed to take the value of x, which is 1 over 6. So to find the value of y, you have to substitute 1 over 6 in place of x, 1 over 6 in place of x, 1 over 6 in place of x. So you must obtain something like 17 over 54 if you are to do this properly as a fraction. So that was the point of inflection. Let's see. 3.12, draw up a table of x, table values of x, actually, f of x, which ranges from -2 to 2. All right, so you're just taking this function that you already have. This is just a table, guys, that you're dealing with. This is 3.12. All right, so remember your f of x, this one just a table. Remember your f of x was 2x cubed minus x squared minus 4x plus 1. Is that 4x? Minus 4x plus 1. So all you need is to just have a table with values of x. Yeah, we can just have our table. Let's just try to put something if we are going to win. It's just a matter of trying, guys, and see if we are going to win here. All right, so that's our ruler so that we can just have our table. All right, we've got the first part here. Okay, another one. This is too much, maybe here. All right, so that's it. We can just have our values. So we're going to have x and y from -2 to 2. So that's -1 is 0, 1 up to 2. So what you simply do, guys, is to substitute. This is the easier question. You're substituting in place of x, you substitute -2 like that. So if you substitute -2, this will be -11, gonna 2, 1, -2, and 2 is going to give you a 5. So this one, guys, I'm not going to waste much time. Just have to substitute your values, direct them. All right, on 3.13 is now to draw the neat graph of between the values that you are given and show the point of inflection. Yeah, there we are supposed to show the point of inflection on your graph. So this is a cubic function. that we have. So we are guys supposed to at least understand or know the shape that you're going to have if you're dealing with a cubic function. So let's just try and put in our points and see what we're gonna have here. So you've got our x and y. If we are to take our values of x, they are ranging from -2 to 2. So that's 0, -1, -2, 1, and 2. Then y, it goes up to -11. So you can just have -5, -10, -15, 5, 10, and so on and so on and so on. All right. So let's see the first point. We've got -2, -11, maybe somewhere here. -1 versus 2, maybe somewhere here. 0 versus 1, maybe somewhere here. 1 versus -2, maybe somewhere here. 2 versus 5, maybe somewhere there. So it's a cubic function. If we are to join these points, we are supposed to have our graph, which is something of this nature. Okay, so that is the graph that we are going to have of f. With the point of inflection, you can even indicate, because if we are to check our point of inflection, it's between 1/6. It's actually less than 1. So it's less than 1. So you can have our point of inflection maybe somewhere here. That's where we've got 1/6, 17/54. So that was 17/54, like that. Okay, so that was it, just to sketch the graph. All right, 3.14, one root of the equation is close to 1,5. So the root is close to 1,5. Use Taylor's method twice. Take note, guys, twice, to determine a better approximation of the root 3 to 3 decimal places. Okay, so what are you going to have? Last time I showed you, in fact, we had another method that we used, and I actually referred to a consideration where we can work this Taylor method using so many methods, actually, where we know that our xn minus, we're going to have xn minus f of xn that we are given over the first derivative of xn. That's where our root is going to be taken from. So here it's actually from our f of x, which is the cubic function that we had, that is going to be your f of x. So we have got our f of x, which was 2x cubed minus x squared minus 4x plus 2. So there we need the first derivative, as you can see on your formula. So the first derivative, we did this one, we got 6x squared minus 2x minus 4. Previously, if you still remember, we had the first derivative, and we are given that the root is close to 1,5. So that's the first approximation that you can have. So I have my x naught as 1,5, the first approximation that we are given. So from the formula, the first value of x that you're going to have is going to be taken from f of x naught, which is 1,5. xn at that moment, it's x naught, which is 1,5. So it's going to be 1,5 minus f of x with xn. So here, when we are saying we are substituting the value of x, which is 1,5. In place of x, you're going to substitute 1,5, 1,5, 1,5. All right, so if you are to do that by substituting 1,5, you are going to obtain 0,5. That's 1,5, not 0,5. All right. By substituting 1,5, guys, I want you to substitute properly. You are going to obtain -0,5. Okay. On the first derivative, you do the same. You substitute 1,5. So this is now 1,5 here. This is now 1,5. If you substitute 1,5, there you are going to obtain something like 6,5. All right. So that means we are going to have this as f of xn, which is -0,5 over the first derivative of xn, which is 6,5. So that's it, guys. That's what you're going to have. So this will be the value of x that you're going to have. So there I just have to use your calculator, which is 1,5. That's a comma I need to get. here. So that's 1,5 minus, you've got a fraction of negative 0,5 over 6,5, which is an endless decimal, but we are told to three decimal places. So this is going to be 1,577. 9 is going to change 6 into 7. So it's 1,577. 1,577. So you do the same thing, just like what we did previously. We are supposed to substitute now into f of f 1,577. In f of f here, you substitute 1,577, 1,577 in everything. You are going to obtain something like 0,049 to 3 decimal places. You do the same on the first derivative of x. You substitute this answer that we got, which is 1,577 here. So you're going to obtain something like 7,768. All right, so using the formula that we had, that means the x that we are going to have as an approximated solution, because this is twice. So that was the first one. Now we are applying Taylor's method twice. So our x this time is now at 1,577 minus our formula is f of xn, which is f of xn, which is 0,049 over the first derivative of f, which is 7,768. All right, so that's it. You and your calculator, guys, make sure that you use your calculator properly on simplifying to 3 decimal places. You must have something like 1,571, not 577, but 571. All right, so that is the better approximation that we can have. So remember, this is not giving you the exact answer. It is giving you a better approximation. That's all about this topic. It's a better approximation that you are having from the given solutions. So we are going to move on to the other part of the question. All right, let's see what we have on the part, all right, which is here. So that's 3.2. So on 3.2, we are actually given a sketch. So I'm just going to remove some of this part that I've done here. All right, so we are given a cylindrical tank. Okay, a cylindrical tank filled with water is a radius of 5 meters. Okay, so that's radius of 5 meters, the height 12 meters. It is drained such that the depth of water decreases. Take note, when it is being drained, that's you are removing water, so it's a decrease that is happening here, and the decrease is it depends on the depth, which is it decreases at 0,3 meters per second according to the depth. How fast is the water draining from the tank? Now we are referring to the volume of the whole water that we have. So this whole water that we have, or the full tank that we have, or whatever cylindrical tank, the water that is in the tank, we are referring to its volume. At what rate is it draining, or at what rate is it decreasing? So whenever we're dealing with rate of change, we are supposed to know that it's supposed to be the rate of change of volume with respect to time. But what we have was this is supposed to be connected to what we are given. We are given the rate of the depth, and the depth in this case is the height with respect to time, which is a decrease of 0,3. So it's negative 0,3 meters per second. We need to find the rate of which the volume is going to decrease for this part. Okay. So what are we going to do? We have got the dH, and we have the expression for the volume, that our volume is given as pi r squared h. So we have V and H here. That means we can have dV dH. Okay, let's see. We can have dV dH from this. So our dV dH, actually, it means r squared is a constant. So our answer is going to be pi r squared. All right, so this can be connected. Actually, we can connect these. Yes, we can connect, because we need dV dt. All right, so let's connect. It's all about connecting your formulas. dV dt, we are supposed to start with dV dH. So it's going to be dV dH by, for us to have dt, we are supposed to have dH dt. So this formula automatically connects, because as you can see, we can cancel the h and the h, we've got dv dt. Okay, so that's how we are going to have our dv dt is the rate of change of the volume with respect to the height, which is here pi r squared times the rate of change of the depth of which is the height with respect to time, which is negative 0.3. Guys, this was a direct question. Okay, anyways, that's what we have, which is negative 0.3 meters per second. So it's now a matter of substitution. So dv dt is going to be pi times r squared, which is the radius. Our radius is 5 meters. So it's going to be 5 squared times negative 0.3. So remember, this is 5 squared, so it's 5 meters squared. So you are going to have square meters, and you have got meter per second. Yeah, that's it. That's it. We can use our calculator there. dv dt is going to be what? Let's see from our calculator, because everything is fine here. All right, so we've got pi, which is shift pi times 5 squared times negative 0.3. All right, which is going to be negative 15 over 2 pi. Okay, of which as a decimal, this can be negative 23,562. Okay, so that's negative 23,562. And that's volume. Volume is measured in cubic meters. So it's going to be cubic meters per second. So there's going to be a decrease of 23,562 cubic meters per each second. So that's the rate of change actually it's calculated. So it's a matter of connecting your formulas, guys. Make sure that you connect your formulas properly. But I think it's pretty clear on this part. On this one, let's check the other part of the question, which is on question 3.3. So in 3.3, I've got 5 marks there to make a total of 20 marks. We are given 3.3. The position of a particle is given by the equation. This is the particle, whereas t is measured in meter and t is time. So this is displacement. T is the time in seconds, and that is indicating the displacement or the distance in meters. When does the particle reach a velocity of 3 meters per second? And that's 3 Mach. When, which means we are referring to the time. The time when, that is the time. So the time that we are going to have when the velocity, we are supposed to take it from the displacement, because this is meter, that is an indication that you are referring to displacement there. So velocity is equal to, all right, let me have my, I can even answer it here, guys. Let me just try and attempt it here. So velocity is equal to the first derivative of the displacement, okay? Acceleration is equal to the second derivative, that's acceleration, okay? Or is equal to the derivative of the velocity with respect to time. So as we are focusing on the velocity, so which means if we are given a velocity of 3, we are going to equate this 3 to the first derivative of s, which is, we are supposed to find the first derivative. A third times 3, that is 1. So we are going to have 1. So it's going to be t squared. We drop the exponent, subtract 1. 2 times negative half, that is negative 1. We drop the exponent, subtract 1. Minus 3t is going to give us a negative 3. All right, so this is the first derivative, guys. We are just differentiating. So solve the equation. 0 is equal to t squared minus t minus the 3 to this side is going to be negative 3. So definitely this will be negative 6. So that means we've got t squared minus t minus 6 is equal to 0. This we can solve factors of negative 6, but when we add, we must get negative 1. That's negative 3 and 2. Yeah. If we multiply this, that's negative 6. If we add, that's negative 1. So we're going to have t minus 3, t plus 2. So this is t plus 2. All right, so we are going to have t plus 2 is equal to 0. So definitely t is equal to 3 or t is equal to negative 2. But we are referring to t, which is the time, and our time cannot be negative. So therefore, our t is going to be 3 seconds. So that's what we had on 3.31. Our time is going to be 3 seconds. All right, 3.32, when is acceleration equal to 0? Acceleration when we said acceleration is the second derivative, but it is now equal to 0. All right, so let's see 3.32 acceleration. That's the second derivative with respect to t. All right, the second derivative. All right, so which means we are supposed to have the second derivative. Remember, we got our first derivative here, which is t squared minus t minus 3. So now we've got that as the second derivative, which is going to be 2t minus 1. This is minus t, so it's going to be minus 1. 3, the constant, that's a 0. So that's our second derivative. But we are given that this acceleration is 0. So we are going to equate this to 0. All right, so that's a 0 there. So definitely you're supposed to solve for t. All right, how can we solve for t? Just transpose -1 to the other side of the equation is +1 is equal to 2t divided by 2 by 2. So t is equal to 1 over 2 or 0.5 seconds. Remember, our time is measured in seconds. So t is 0.5 seconds when the acceleration is equal to 0. So these are the typical questions, guys, as you can see. Yeah, that's how they actually asked this question. And this was actually having a total of 20 marks on question number 3, which are the applications. These are the applications of differentiation, the application of derivatives. Just like integration, you must know your integration, and also you must know the applications of integration so that you'll be able to obtain full marks in your final exam for mathematics and 5. But for now, that's it, guys, till we meet again.